Hello, everyone, and welcome back to HashiConf Day 2. Who is excited? I don't know. That didn't sound very excited to me. Who's excited? Awesome. How many people attended the evening social last night? Yeah? Was it a good time? Great time. Beating me with my own words. Well, thank you, everyone. We're super excited to have you back here today. I just want to remind everyone very quickly, no open food or drink in the theater, but today we have boxed lunches. So you'll be able to grab a boxed lunch and head right into the theater to eat. We're also going to add a little bit more seating since we saw some people standing yesterday. We're going to get right into it. I'm super excited to welcome back on stage founder and CEO of HashiCorp, Mitchell Hashimoto. Please give it up.
All right, welcome back. Welcome to day 2 of HashiConf. Yesterday was a pretty exciting day. We were able to announce a lot of things, but especially a couple new products. We already have almost 1,500 stars on Auto and around 500 on Nomad, and I saw a lot of people running it as well. There's a lot of pull requests. I actually saw some pull requests from people at the conference, so the community is already growing around these tools, which is really good. Auto in particular is already getting smarter. We're getting better NPM installation methods, PHP installation methods. It's cool to see this starting to happen. So thanks everyone here for checking it out. So today we're going to do something a little bit different. Whereas yesterday we focused on product announcements, I got a lot of questions yesterday. We collectively at the HashiCorp booth and around, we got a lot of questions of how do we design tools? How do we come up with the ideas that we have? How do we execute those ideas? And also, how are they all supposed to work together? There's 9 different tools, 8 open source projects, and using them together can seem kind of confusing. So we're going to talk about those aspects of things today. So I want to start by talking about something we call the Tao of HashiCorp. We've blogged about this maybe a little over a year ago. But what the Tao is basically the first principles of HashiCorp. It's sort of the unspoken ideas that brought Armand and I together professionally, in addition to being friends. They're ideas of how to build things, and I think they're general. I don't think they necessarily apply only to infrastructure, although there's some that will seem to apply more than others. But I think really if you're building anything, these things can apply to you, and I want to go through them because they're very, very core to how we think about solving problems. So the first part of the Tao is something we call workflows and not technology. And this is the idea that sort of as Luke said yesterday, like progress is going to move forward. So software, hardware, this stuff's going to change. It's going to change really fast. So we can't bind ourselves to a specific technology. And if we do that, then when it changes, then we're in a lot of trouble. So instead, when we start designing a tool, when we see a problem, we start workflow first. We start thinking, how do we want this to feel? What do we want it? How do we want to work through the problem? Not necessarily how's it going to work, what technologies is it going to use underneath. Once we get the workflow through, then we start picking current technologies that we should integrate with. And you could see this Tao in particular in almost all of our tools. Vagrant works with multiple providers. Packer could build virtual machine images, but it could also build containers. Terraform can launch all sorts of things. Nomad yesterday has the task drivers that could schedule containers or schedule VMs. This idea is that the workflow is the same. You Nomad run all those things. You Vagrant up all those things. You Packer build all those things. And yet, as the technology changes underneath, it's able to adapt. The next idea is simple, modular, and composable. And another way to put this is perhaps by comparing it to the Unix philosophy of breaking down problems into smaller, easier to consume blocks. And this is very much how we've done things. So the idea here is instead of designing something large and holistic that tries to solve the entire problem in one tool, we break it down into smaller, easier to consume blocks. And this is better for a lot of reasons. It's easier to adopt things. It's easier to understand the boundaries of things and how they fit with other tools. It's also easier for tools like Vault to audit the code base. If we had built Vault into something like Console, it would have been much more difficult. If all 8 of our tools were one tool, it probably would have been impossible. And you also avoid issues where you don't want to update your service discovery and suddenly realize that all your secrets were exposed. Like it creates these nice barriers of protection. And the next thing is communicating sequential processes, or CSP. And the idea here is that autonomous processes should be able to communicate over a network. And so we have all these different things running and doing their own thing at the same time, but they should be able to communicate and update each other on their status and adapt to each other through communication. In computing, that's usually the network. And this isn't restricted to computing. This is actually just the best practice pulled from nature itself. All of you are walking around CSP things. The human body is a really great example. We have the respiratory system, cardiovascular, all these sorts of things, all executing on their own, but connected sort of by the nervous system, which is more the network, letting them know what's going on. And this is core to how we do things. Console's its own running thing. Vault's its own running thing. Nomad's going to be its own running thing. And they communicate statuses to each other, but they're not bound to each other. Then there's immutability. This is perhaps just due to this word being used a lot in DevOps right now, seemingly the most appropriate for DevOps, but I think it's also very general as well. The idea of immutability is just being able to fossilize something, being able to say this is a version and this is a snapshot of something. And when you're able to do that, it's a lot like version control. You could roll back, you could roll forward. There's a history, a solid history of how things have changed. You could get clearer auditing and things like that. And it's more robust. It's it's more difficult to mess things up once they're running if you agree to just never change things that way. And I think one mistake with immutability, particularly in the DevOps world, is thinking about it as a one big immutable thing. Instead, we really have to think about it as layers of immutability. And a really great example of that is Nomad. When people talk about immutability, when we've talked about immutability in the past, one big issue has been they look at Packer as the sole sort of immutability engine that we have, and they say, well, when I deploy, I don't want to build an AMI for every single application. And it's totally true. So you could think of immutability as 2 different layers. There's the machine layer, which would be the AMI, and then now we have the application layer, which is a container or something scheduled by Nomad. So Nomad is a tool for breaking down immutability into multiple layers. And that's that one. The next one's versioning through codification. So without codification, and this is in ops in particular, without codification, before that we had effectively oral tradition. It was a new person would come on, and how you would learn how things worked was just over time talking to the person and watching it happen. And this is sort of like how human history has evolved, but it's a lossy method of education because you only say what you could remember, and you forget details, and those details are pretty important. So instead, we prefer codification, which is the idea of taking the knowledge that you have, codifying it into text, and then using that as the source of truth. And this, paired with something like immutability, version control, gives you a history and things like that, so that when someone comes on, they could learn, and they could also see how it's changed over time. On top of that versioning through codification, there's automation through codification. So we're getting more and more servers all the time, more and more complexity, more and more applications for developers, and doing things manually just isn't scaling. People just can't keep up with how fast the technology is moving, so we really need automation. And there's automation such as bash scripts, and then there's automation which is more specific codification, so higher level DSLs and things like that. And we prefer codifying all this knowledge because it's an exact executable blueprint of sorts of how to get things done, and it goes hand in hand with learning as well. Then there's resilient systems. So this sort of goes with as infrastructures grow, they need to be able to handle failure better. And to do that, there's various ways. Distributed systems is one, if they work. So distributed systems are really important, but also just considering that especially if you're in a CSP model where things are communicating, being able to handle unexpected inputs. If people send you the wrong thing, if they think you're the wrong person and communicate with you incorrectly, just handling that gracefully and degrading gracefully So resilient systems are really important to think of when designing tools, and we try to think of that as well. And I think the best example of resilient systems for us is Terraform. Terraform is able to spin up thousands of machines with hundreds in parallel, and we knew that we were going to get failures. And we knew that the network would go out. We knew that the cloud providers could be unreliable at times because they have their own ops to deal with. So we built the idea of partial state into Terraform, and it's really the idea of making Terraform resilient, making it so that it could see the desired state of where it wants to go, see the current state of where it is, and know the steps to get there. And the flip side is if we didn't build Terraform as a resilient system, I don't think it would be in use today, because you would run Terraform with a real infrastructure, it would fail halfway through, and you'd be stuck with hundreds of dangling resources you'd have to find and being billed for, and I just don't think it would work. And then finally, pragmatism. So I listed all these things that we firmly believe in, that are principles that guide how we design things, and we aspire to follow these, but we're not dogmatic in saying that this must be the way things are. We're not going to say that if you're missing resiliency, then it can't work. In some cases, perhaps it can't, but in other cases, if the best solution just isn't to be resilient, if the most pragmatic solution isn't to be resilient, then we'll go with it. So I wouldn't think of it as a compromise either. It's more of being open-minded to accept that we may be wrong at times and our principles may not apply at times. So that was the Tao. The Tao represents sort of the first principles of HashiCorp. It's existed sort of unspoken between Armand and I for many, many years, and we finally put it down into words over a year ago. But it really guides how we build things. And like I said, I think it's general to a lot of other problems as well. So next, I want to talk more about vision. So this is more specific. This is applicable just to us with DevOps, what we're trying to do as ourselves as a company specifically. And so for us, the goal has always been to make getting from development to production easy. And we're talking about real production. I'm not talking about we could get one server up and get it running, but as like a demo. Like we want to get to real Netflix quality sort of infrastructure, and we think everyone could get there through automation. So when we started the company, though, we only had Vagrant. And I talked about this yesterday, that we only had Vagrant. Some people viewed us as an IDE company, things like that. But Vagrant already had a lot of users when we started, and it was very successful. And so it had to be our starting point. It had to be where we came from. Perhaps if we didn't have Vagrant, we could have started with something like Consul. Maybe. It's sort of the road not taken, so we'll never know. But since we had Vagrant, it was where we were going to start from. And this was already planned out in 2012. And sort of, I get asked all the time, do we come up with product ideas sort of on the fly? And honestly, no. All the products we've released to this point, we've thought of since 2012. Yes, all of them. So I'm going to go in order of in the order we built them, why we built them in that order, and sort of how people were reacting at the time, and how we were adapting to the community and the industry at the time. So of course, we had Vagrant, our starting point. The challenge being we were viewed as a dev company, and if we had any chance of giving you Consul and running it in production, we needed to build trust that we could build more than development tools. So this really defined the roadmap and the order we would go. Next, we built Packer. I'm sure many of you remember this. And the immediate response, I mean, it was part of how we blogged about it and messaged it as well. But a lot of the response was like, oh, the Vagrant people built a tool for building Vagrant boxes. And this isn't wrong, but it's also not completely right, because it was also our immutable image builder. It was also the way that we saw building AMIs. And containers existed, but Docker didn't exist then, and they weren't very widespread. So it didn't do that then, but nowadays it could do the granularity, it could do application containers, and it could also just do application like slugs. It could use build packs and just build tars and things like that. The idea is it builds the immutable layer, whatever granularity of immutability that is. So then we released Surf and Consul, and Surf in particular is where things started to get weird for people. When we released Surf, people were excited about it in a way that it was interesting, but we also got a lot of confusion, which is like, why are you even doing this? This doesn't have anything to do with Vagrant. And we even started to get people at this point that were asking us, like, are you just throwing darts at a wall and like hoping one of them sticks? And it's funny because we didn't want to give away everything that was coming on the down the path, but at the same time, that wasn't true at all. If you look, Vagrant was a dev tool, Packer's an operations tool, and then the next step we wanted to take was to give you a production tool, something that actually ran in your data center and something that could arguably cause downtime, that was in the path of downtime, and that was Surf and Consul. Surf was weirder, but we needed Surf to build Consul, so it was a building block to get there, and now Surf is the underlying mechanism for Consul as well as Nomad, so it's really paid off. But Consul was the first thing that could technically cause downtime, so we were really careful about that development process, and I think we did really well when it came out. And you know, I'm happy to say, like, up to this point, we still, knock on wood, haven't had a single incident of data loss ever in Consul's history. So that sort of solidified us as being safe in the production space, but people didn't know what we were doing still. It still just seemed kind of random. We just had these things. So the next thing we built is Terraform, and this is really where people started to get it. We started to see hints around Twitter and blog posts and things where people were starting to figure out what was happening. And Terraform, of course, starts a bunch of servers and other resources, but this is where we really started to be viewed as a DevOps company. We started to see people reference us as a DevOps company. We were no longer called the Vagrant company. The dev being classified as an ID company was totally gone by this point, and we're moving forward. So we have dev, ops, prod, and then ops again, basically, if you were to put them in a category. Then Vault came out this year. At this point, we're pretty solidly a DevOps company. We had made this transition, I think, pretty well. And now we were just heading towards this vision of how do we get from development to production. And we had Consul for storing data, key value data. But for immutable infrastructure, which is one of our core sort of principles, you can't put things like API keys and stuff. It's harder to put them at runtime in there with tools like config management because that build step doesn't exist. Or the build step is too early that you can't get these secrets on there and secure them. So we needed a way to store secrets. Consul could store data, but it wasn't great for securing secrets. Even with ACLs, it's not a proper secret storage solution. So we decided to build Vault. And then it's sort of leading up to today. We had all these pieces. Even up to Terraform here, even if you ignore Vault, like let's say you store secrets in Consul, even if it isn't secure, up to Terraform, we had built all the pieces necessary for a really rudimentary immutable infrastructure, dev to prod sort of system. They were all there. You could start servers, you could get service discovery, you could get dynamic configuration with Consul and Consul template. You could build the images with Packer, and you could deploy them out. But the feedback loop is still pretty long. I think people looked at those tools, and the people that were starting to get what we're doing tried to live this vision, and thought that it could be better. You know, the feedback loop of waiting 10 minutes could be better, and it works though, and it's just a starting point. And the thing is, once you realize what we're doing, you could hopefully trust that we're going to improve upon that loop, make it better, make it faster over time, and that's sort of what we did yesterday. So we released Nomad, which is a great optimization in terms of getting more density and getting faster deploys in your infrastructure. So Nomad now splits the immutability from the machine level down into two levels, the machine and the application level. And we can make this much faster. You're now updating your AMIs much less frequently. That process still takes 5 to 10 minutes, but you just don't do it that often. Whereas the application you might be deploying dozens of times a day, maybe hundreds of times a day, but you could just keep it going and keep it going. And then there's auto, which we're going to get to in a second, but is important to the whole process. And I think something that's really interesting is Nomad is a container scheduler. And like I said, we had planned all this out in 2012. And Nomad's a container scheduler, but containers weren't there then. But we knew that you needed to have application level immutability. And containers were probably the right choice, even if a runtime didn't exist then. But this was all sort of planned out. And that shows you how we also adapted to things as they occurred. So as Docker got released, as these other tools entered the ecosystem, we didn't just go directly bullet by bullet with our plan from 2012. We adapted it. Nomad Docker is the clear use case for using Nomad. It's the obvious way to make things really simple. Raft actually became more prevalent between Packer and Consul, so Surf and stuff was happening between there. So Raft became the obvious choice, whereas originally we had planned to do Paxos, which would have been some level of sadness. So we were able to adapt as time went on and make things work. But because we focused on the workflow and not the technology, as these things happened, it still was valid, and we've also built something that's extremely robust in being able to manage these more legacy infrastructures, as well as infrastructures only used by Silicon Valley and people like that. And I think, again, that's part of sort of what Luke said, is like saying yes to your customer. Like, we're able to do that with very little compromise because we focus on workflow so much. So this is sort of a diagram of how we viewed all this stuff working together with a lot of lines. So the idea is you start in Vagrant for development. You could pull secrets out of Vault sort of anywhere on this flow. After you work in Vagrant, then you go to Packer. Packer builds the image for you. Again, whether that image is an AMI or a Docker container, it doesn't matter here. We're not binding ourselves to technologies. We're talking about the workflow. Then next, you go to Nomad, which deploys this thing. Nomad runs on servers that are started by Terraform, up in the top right. And then there's Consul in the bottom right, which is sort of Nomad's registering things with Consul. Consul is communicating back to Nomad with monitoring data. And there's sort of a loop there, and Terraform's the same way. So we built this workflow out. And I talked about it yesterday. This is, I mean, you look at this and think that there's a lot of things happening. There's a lot of arrows. And it seems very complicated. So even though we've built individual tools that do something really well, it still doesn't make the whole process easier to understand. And that's why we built Auto. So you could see the box around the whole thing is Auto. And for those of you who have started to play with Auto, who've already contributed to the source, like, this makes a lot more sense if you understand the implementation as well. But at the same time, we built the tools. You can get fully automated development to production. We have codified throughout. There's no tool in here that is purely command line flags. Like, everything through here has a declarative configuration model that can be codified all the way. You could take what you know in your head and get it down into text version and make that immutable as well. And again, the flexibility for new technologies is really important. And so this leads to Atlas, which is the one we haven't talked about to this point. And I think which is a common point of confusion. So we had the foundation of the vision done, and we build these all as open source. And the analogy, the idea I like to make here is we've given you a toolbox, and the toolbox has a ton of things in it. It has hammers, it has screwdrivers, it has a lot of different screws and nuts and bolts and things like that. And you're looking at this thing and you're like, well, I really want to build a house, and I'm not quite sure how to build that house with what you've given me, even if we've given you the tools to do so. And so the idea behind Atlas was to give those people a house to work within, to be able to automate all aspects of this pipeline, to automatically set it up, to be able to give someone a self-service workflow. How do you turn this dev to prod thing and make it more Heroku-like, make it more self-service? How do you connect it all and view it as a pipeline visually? And how do you encourage teamwork? How do you bring in collaboration, bring in ACLs, bring in security, and things like that? And that is Atlas. So an analogy I like to make is the relationship between our open source and Auto being the wrapper around all of our open source, and Atlas is a lot like Git and GitHub. And this diagram helps make a lot more sense. So again, I'm not talking about Git as like the technology, like a version control technology, but as the idea that Git is the open source thing, the workflow thing, and then GitHub gives you more collaboration, UI management, visualization, things like that on top of it. So you can see that I have here Auto is open source, core functionality, and a CLI. It allows developers to work. It allows you to work on your laptop. And then on the right is Atlas, which gives you the management, collaboration, security, and an interface to view all this stuff. And so that's how Auto relates to all of this stuff, and that's how Auto relates to Atlas, and how everything sort of relates to how we commercialize and make money as well. So the 7 tools require a significant learning curve, and and Auto automatically manages these tools. And I don't know how many people have played with Auto yet, but Auto automatically installs things like Terraform. You don't need to know how to set up Terraform. It automatically installs and bootstraps a distributed system like Consul. The next version automatically installs and bootstraps Vault and Nomad. And the thing is, you don't know that's happening under the covers, but we're removing that complexity for you by doing it automatically. So then, Armand and I had this vision, and the 30 people that work at HashiCorp have been helping add to it and build upon it and make this a reality over time, change it with how things are, how the market in general is changing. And today, I mean, even a year ago, you could already live within that future we dreamed of. But since a year ago, it's gotten a lot better. So we live in it every day. Our customers and our users live in it every day. And I want to show you how exactly we do that. So I'm going to do this by showing you how we do it for Atlas and with Atlas. But this is also exactly how all our customers, Mozilla, Condé Nast, the people that I showed yesterday, also do it. But I'm going to show you us because I could show you the internals and show you actually like our services where it would be pretty hard to do that with theirs. So to do this, for our workflow, we work with primarily 3 tools. So there's GitHub, which I think is obvious, so I don't need to say anything about GitHub. But it's where we store all our code, but not just application code, but infrastructure code as well. Then that heads into Atlas. So when we commit with GitHub, Atlas then picks it up and is the workflow engine for getting from dev to prod. Git is really the engine, and GitHub's really the engine from getting from laptop and developing into the next stage in the pipeline, whether that's CI or so on. And then the final piece is Slack. And Slack is just our notification hub where we receive messages and interact with Atlas without actually being on Atlas. And generically, these could be just left could be version control, and right could be anything chat related. But these are the 3 primary necessary tools for us to work the way we want to work. So let me describe to you a part of Atlas's infrastructure architecture that we're going to just be walking through today of how we change. So Atlas has a piece of itself called Logstream. And I don't know how many people you here have used Atlas, but when you run something like a Packer build in Atlas and the logs stream into your browser to show you how it's executing, this is the service that's doing it. Atlas is built as a microservice-based architecture. Atlas is built up of over 35-ish microservices, and Logstream is one of them. And the way it works in general is when you submit something like a Packer build to run or Terraform run to go, we queue it in a queue. It goes out to a dedicated server because we have to be able to run things like VMware, so we can't run that in the cloud. It goes out to a dedicated server, and that dedicated server starts running it. As the logs get outputted, we send that back over a SSL tunnel back into AWS, append it to Redis, and Logstream is the thing that streams this out of Redis into your browser. And then once the build is done, we take everything in Redis and snapshot it and commit it to S3. And Logstream is also the thing that makes the decision, which is it in Redis? Is it hot? Is it live? Is it happening right now? Do I need to stream it? Or is it just all in S3 and I could just serve you the whole log? So whether it's history or live running right now, you just ask Logstream for the logs and it finds it and gives it to you. And Logstream is the thing that I'm going to just show you us going through the whole process today, just because it's one of our services, but they're all very much architected alike. So we currently develop everything within Vagrant. We're moving a lot of stuff over to Auto, but only a handful of our services out of the 35 are moved currently. There's nothing sneaky here. I don't think I need to talk about it. We use Vagrant in the same way. We've been using it for a long time. So let's just start from what happens after you get pushed. So say you worked in Vagrant, say you're done building a new feature into Logstream, and you then push from this point out. Git receives the commit. We set up post-receive hooks into Atlas, and then Atlas is running Packer for us. So we're going from that Vagrant to Packer step right now. And what Packer is doing here is compiling the app. And this is not building an AMI. This isn't that level of immutability. We're doing the application level immutability right now. So this is running actually building a Docker container, but it's using a build pack. So we just use Heroku build packs to do all this. using Packer. And we'll blog about that another time of how we use Packer with Heroku build packs to make application binaries, but that's the next step. You could see the history of all this stuff. So we could see Justin was the one who made a change, and we could see it merge from a pull request. You could see when and so on. You could see it's compiled successfully. You could click it. You could see the Packer output, that sort of thing. This is sort of the benefit of Atlas versus running Packer on your own. After the build is complete, that triggers then we use AMIs currently, so that triggers a machine image build, and this is Packer again, but this is wrapping that application back into a machine image for deploy. This is something that's somewhat optional. In a nomadified world, which we're moving towards, this probably won't happen because what we built in the app compilation step could be handed to Nomad directly. But currently, a lot of our services are just AMIs, so then we head into this next step. Just like apps, you could see a history of builds. A difference here is some could come from GitHub. You can see some are triggered by a configuration push, and you could also see the configuration changes coming in from Packer. So it just gives you a central way to see all these changes. And it's also important to understand that the applications could come from Git, these could come from Packer, and it could be a devs versus ops sort of thing. If they're the same person, that's great, but if you still have some silos in your organization, if they're separate individuals where ops is managing Packer and devs doing application code, then they could come in separately and they could share code with each other. After the build process succeeds, then we invoke Terraform. So continuing to follow along that diagram of Vagrant Packer, skipping Nomad right now because that's not how we do things currently. And then going to Terraform to launch servers and deploy this thing. We also have Atlas execute Terraform. So you could see that this is the first step that could potentially cause downtime. The rest are just building things, but this is the first thing that could actually cause problems. So Terraform has a feature called planning, which tells you what would happen if you were to execute that Terraform change. And so what we do in Atlas is we actually generate the plan and then show you a confirm and apply button or a discard. And so this step requires approval, and it's optional. This is the default. You can say just automatically always auto confirm the plan, but by default, you probably want to confirm right now. And we notify all this stuff via Slack. So this is where Slack starts coming in. This is our ops channel. This is sort of what happens. You can see a notification down here of the build finishing, letting us know that Logstream had a new version coming out of Packer. And then below that, Atlas then tells us that we're trying to deploy it and it needs confirmation. So Jack Perks is trying to change something and needs confirmation, so you could click that. You see the green button. If it looks good, then you could click the green button, and that leads to this. So the next step is then to apply it. So plan, apply. It applies successfully, and you could see sort of all the output. And the benefit of running this, here versus on your laptop is Atlas helps ensure that nobody else is running a deploy at the same time, that you're not clobbering each other's infrastructure. You can see the history of things. You get this confirmation. We store who actually confirmed it, so you could look back and if something caused problems, you could see you could sort of like a git blame of your infrastructure. And then once it's deployed, we can see the health of our entire data center. So this data comes from console. It gives us all our services. These are actually all the services in Atlas. And green is good, green is healthy, and you could see that. And we use something kind of neat here. I think we've documented it, but we blogged about it called SCADA. And this is actually accessing data in a private network that Atlas isn't running on. So Atlas is running in its own VPC, its own private network, and what it monitors is it could be in a separate VPC, it could be in a separate data center. It doesn't need to be in Amazon. It could be anywhere. And the way this works is something called SCADA. And what SCADA does is it's a flag you might have seen on console. It's also coming into Nomad, where it creates an outbound connection direct to Atlas that controls only sends specific data over an encrypted communication. So we're able to receive monitoring events and things from your private network if you configure it that way. So you don't need to run it on the internet and things like that. And like I said, Nomad is going to get SCADA as well. Actually, Nomad 0.1 has the foundation for the connections in it, but it can't connect to anything yet. But when Nomad gets it, this is how Atlas will be able to also deploy applications into your private infrastructure from outside. And this is really how easy it is to get from development to production, and this is how we deploy every single service. The editor and git push is the only thing we have to do on our laptop. The rest is responding to Slack notifications, watching builds happen in a UI, in a browser, hitting green buttons, and watching things sort of go through. But let's consider when this doesn't go particularly well. Let's consider an ops event. So in this case, another one of our services called BinStore has gone down. There's red. It looks red. This happened here. And this would give us a notification in Slack as well, or PagerDuty, or SMS. There's various different ways you could get these notifications. But this sends us this error, and now we need to respond to it. The person responding it could be a dev, could be an ops person. Again, we're working through this workflow here, and whoever that person is doesn't matter too much to us. If you're practicing DevOps more effectively, then perhaps they're the same person. But if you still have very separate, reliability teams and things like that, then it could be anybody. So then to debug it, we use Vault. We could use the new feature we came out with yesterday, which is Vault SSH. You could SSH into the server, start figuring out what's going on here, debug this further. And then we get the fix. And the fix could be the application has a bug. Maybe BinStore has a bug, which caused it to go down. It could be that the machine image itself is misconfigured. Maybe we forgot to configure log rotation, so it's filling up the disk. Or maybe the fix is a Terraform change. Maybe the instance size is too small. BinStore is our service for serving all large things. When you download a Vagrant box, if you downloaded a Vagrant box yesterday, it came from BinStore. That's where they come from. And so maybe we need to make the instance size in AWS larger. Larger instances, certain larger instances in AWS have larger network pipes attached to them. So maybe we need to make the instance larger. And that would be a Terraform change. But whether it's an application change, a Packer change, or a Terraform change, the solution for us is always code it in whatever format you're working with, and then git push it. So it doesn't matter. So whatever the fix is, this is how we're going to make that start happening. If it's an application, you kind of know what's going to happen. Everything we talked about previously is what happens. If it's infrastructure, let's assume it's infrastructure because you haven't seen that yet. Then you would modify Terraform and then push it. And because we're treating all our stuff as code, we could also use a workflow that we've previously really only used with applications. So in this case, we actually manage our ops a lot like an application. We branch, we modify the Terraform. After we modify the Terraform, we make a pull request. The pull request describes sort of what we're trying to do here. And then, again, Justin's fixing this thing. And then we integrate with the status API of GitHub. It's the same way something like Travis CI would, and actually run a Terraform plan. So we didn't show it down here because there was some review and stuff. But you can see the green check mark on this commit, which is a success. The Terraform plan finished successfully. And this is starting to integrate with Atlas. And again, showing you the benefit of that versus just running it on your laptop. If you actually look on Atlas, if you clicked that green check mark or clicked to the things at the bottom, this is what it would look like. You could see that this came from GitHub. If you look at the link on the right, it actually links to the pull request. This will be in history forever, so you could actually see where this came from and how things work. The plan output is down here below, so you could see that, and you'll notice that there isn't a confirm and apply button. You can't apply this because it's in a branch. It's not applicable. We just want to show you what would happen if you merged it. So let's say you merge it, looks good, gets the +1, ships it. You then get the confirm and apply button. It's mergeable. You have the plan of exactly what's going to happen. This is a benefit of the plan, shows you what's going to happen before it can. And then you also get Slack notifications. So these are all coming through this whole time as well. So you hit apply. This is very similar to what you've seen. The apply happens successfully. And then sort of done. Your infrastructure gets healed. There's a screenshot I didn't put here, which is that the changes link up here, which sort of shows the Git branching, commit branching. You can actually see changes and actually see all this stuff, the state changes happening in your infrastructure and history. That's sort of like the Atlas analog to the GitHub commit view. So with the commit view, obviously you can see all the commits to your application. With the changes view here, you can see all the changes to your infrastructure. So these are not just code changes, which are there, but these are Terraform runs, Terraform plans, rejected plans, applied plans, monitoring changes, new servers coming in, registering with SCADA here, leaving, all sorts of stuff are shown there. So you could actually get a single stream of changes in your infrastructure. This is pretty interesting because with that resilient systems idea, you get systems that sort of heal themselves. And one thing we figured out once we had this alerting history is that we actually had a lot of flapping services, and it didn't affect actually like a lot of our uptime because we were gracefully degrading to other things. But we did have a lot of things that were coming in and out, and that alert history helps give you that. And then sort of just this week, we started rolling out this. So this is the pipeline view of everything. We showed you a lot of UIs today, a lot of clicking. But really what you sort of want to see is what's happening with my application right now. So if you were to log into Atlas, you get this sort of view. And this is more of the unification of everything. So if you could completely build this process yourself using our open source tools. That's the idea, is that you could do that. But for the folks that just want a solution, then this is sort of what you could see. It unifies everything together, even though this is coming from Vagrant, executing Packer, executing Terraform, interacting with console, and soon to be interacting with things like Nomad and Vault as well. It all just shows up in a single UI that you could just follow through. So this is looking at Logstream, looking at all the versions we have, and almost everything in here is a link. So the SHA is a link, goes to GitHub, shows you what has changed. The people are links, and then every step is a link as well. And you could see things like in the top, it's at the point where it needs user action. The Terraform plan exists, but it hasn't been confirmed yet. Or at the bottom, there was an error in the app compilation step, so we just canceled the rest of the thing. And then in the middle, they all succeeded. And you could click any of those to go and see what happens. And so just in review, I just want to talk about Atlas. It's application compilation, image building, deployment, infrastructure management, monitoring, and enabling collaboration and ACLs. ACLs I didn't talk about too much, but all that stuff could be ACL'd by team, by org. We follow the GitHub model in terms of how you could break your team. You have an org and you break it down into teams. Each team could access different things. And actually you could open source the whole thing too. So I don't think we've done this with any of our things yet, but for example, we build the Vagrant boxes, the HashiCorp, Precise64, and some other boxes through Atlas. And we could actually open source that whole process. So you could actually view the builds as they happen and see that sort of thing. And we plan on doing that soon. And then there's Vault, Nomad, and Auto. And we didn't talk about these too much, mostly because Nomad came out yesterday. And then Vault just doesn't have an integration yet because it's also so new. We use Vault a lot under the hood. For Alice's implementation itself, all the passwords are encrypted using Vault and things like that. But also we have integrations planned for all of these in the coming months. Auto in particular is really important. I'm already getting questions, which is like, I've used Auto to deploy something, but how do I do it with a team? This is going to be the way that you do it safely. And Nomad is going to come in very quickly as a way to just speed up these deploys, be able to schedule things and use that. So this is all built, guided by the Tao of HashiCorp. This guides not only our open source projects, but also how we built Atlas itself. I went through all of them. You could read them by Googling for the Tao of HashiCorp. It's all in much more detail in the blog post as well. And this is really the embodiment of our vision of getting from development to production. We've given you the open source tools so you could do this completely on your own. We've broken them down into individual components so you could choose what's important to you. Start with service discovery, start with image building, and do that. But also we've built the entire solution if you want to go that route as well. And that's all I want to talk about today. So thank you. Have a great day too. I hope this answers a lot of questions. And please come talk to us at the HashiCorp booth if you have any questions. Thank you.